For our research, we ended up focusing on the determination of volatile phenols in beer from smoke-tainted hops post-fermentation. In the summer of 2020, much of the western United States had wildfires that impacted the primary growing regions as hops, also known as Humus lupulus. Volatile phenols are primary compounds used as markers that help determine the levels that the wildfires affected the hops. Guaiacol is the first primary marker. It usually comes in higher levels compared to other ones. It contributes a sweet, smoky, and aromatic aroma and definitely has an influence on what is perceived the affected hops. The next is 4-methyl guaiacol, which contributes sweet, spicy, and vanilla flavors and usually has lower levels compared to guaiacol, but definitely has an effect on the hops themselves.
So for materials, we used two different samples of hops. We used a control hop and a smoke-tainted hop. Both were provided to us by John Ihas, which is a division of Barthas. Both were provided in whole cone form. And essentially, we processed these using a blender just to ensure that all the volatile phenols as well as the hop material were nice and homogeneous throughout the sample. Regarding yeast selection, we used a California Ale strain as well as a London 3 strain. Both were pitched at 1 million cells per milliliter per degree Plato. And then the wort that we used for all of these different fermentations was a proprietary recipe provided by New Belgium in the New Belgium Brewhouse in Fort Collins, Colorado. Regarding instrumentation, we used a few different instruments. We used 2 GCMSs. That stands for gas chromatography mass spectrometry. The first was focused on determining the amount of volatile phenols. This is going to be checking levels of guaiacol as well as 4-methyl guaiacol. The second was specifically checking hop aroma as well as yeast volatiles. This was more just to ensure that fermentations were healthy. As a supplement to determining fermentation health, we also used an Anton Par densitometer, which measured pH, EA, and ABV of our beers post-fermentation.
For a hot work procedure, we ended up having 3 different vessels, 1 smoke filtered, 1 smoke unfiltered, and 1 control hop unfiltered. They ended up boiling each vessel for 45 minutes to ensure the hops were isomerized, and from there ended up cooling the wort down to 21 degrees Celsius and pitching London 3 yeast at 1 million cells per milliliter and fermented them for a few days.
Regarding cold wort procedure, we had 4 different samples. Each either had a smoke hop component or a control hop component, and each either had a London 3 or Cal Ale yeast added to it. Essentially, we started them all off the same and then added that smoke-tainted component into 2 of them and then the control mosaic component into 2 of them. Each was then pitched with their respective yeasts at 1 million cells per milliliter per degree Plato. And then we placed all of them into a water bath with airlocks just to ferment them out for a few days.
The fermentation data helps us know that we had consistent fermentations, which if they were off or different, they could influence the different volatile phenol levels. As you could see, the same yeast strains were similar fermentations and all the levels of ABV, EA, and pH. The hot wort takeaways consist of showing that the filter does have a little effect on guaiacol levels, and that the control, as you can see, there's already some guaiacol from the malt most likely in solution. But once you look at the smoke unfiltered and filtered, the levels of guaiacol and 4-methyl guaiacol are much higher. And by observing a rough sensory evaluation, we determined there was a difference in each of the samples.
So what were our takeaways for cold aerated wort? The amount of guaiacol and 4-methyl guaiacol is going to be higher in the L3 sample as compared to the ale sample. This likely has to do with a lot of our fermentation that was shown in a few slides previously. The ale yeast fermented out a little bit further than the L3 yeast. We expect that's because the fermentative action is volatilizing more of the volatile phenols off when there is more fermentation. So regarding the discussion of part 1, the research in this field of smoke-tainted hops is still really in its infancy. We really have to do a lot more research to determine a lot of things like sensory thresholds of these two volatile phenols, as well as smoke exposure, time and intensity, and how that affects the uptake of VPs in the hop, flower, and vine. The different brewing yeasts effect on guaiacol and 4-methyl-guaiacol levels, and then determining whether or not the smoke exposure based on stage of hop production really affects the end product.
Overall, some of the takeaways from this, we can determine that boiling does have a little effect. Different yeast strains have an effect on the VP levels, and filtering has a slight effect on the VP levels. But there's much more research to do, as mentioned, with different yeast strains and how they could affect each one, along with using a pilot system would help us get a lot better results that would be able to translate to the commercial production scale compared to the lab results that we have here.
We would like to thank our great mentors, Stacy Williams, who's a senior chemist at New Belgium, as well as Justin Alexander, who's an analytical chemist at New Belgium. Additionally, we would like to thank John I. Haas, a division of Barth Haas, for providing both the control and smoke-tainted hop samples. And then finally, we'd like to thank our great teachers